Assalamualaikum and hello everyone. Today we will be presenting our topic 2 analysis titled Correlation between Age and Subjective Energy Levels among University Students. My name is Nur Shafika Natasha and together with my team members Iman Hazira and Nico Libang, we will explain the findings of our study. Breakfast habits are often associated with better alertness, energy stability, and improved daily performance. While many studies highlight how breakfast consumption can influence energy level, it is also important to recognize that energy can be affected by demographic factors such as age. As individuals grow older, changes in metabolism, lifestyle, and daily routines may influence how energetic they feel throughout the day. Even though our dataset includes several breakfast-related variables, only numerical variables can be used for correlation and regression analysis. Therefore, this study focused specifically on age as a potential factor influencing subjective energy level. By analyzing secondary data from 40 respondents, our objective is to determine whether age show a measurable relationship with daily energy levels and whether younger or older individuals tend to report higher or lower energy scores.
Now, I would like to present on the problem statement. We have 4 problem statements, which is first, the dataset contains various breakfast-related variables, but only numerical variables can be used for correlation and regression. Age is the only suitable explanatory variable available for statistical modeling. Third, it is unclear whether age has any measurable influence on daily energy level. The fourth is the study aims to determine the strength and direction of the relationship between age and energy score using correlations and simple linear regression. Now, I would present on the objective. We have 4 objectives as well. First is to examine the relationship between age and subjective energy level. Second, to determine the strength and direction of the correlation between age and energy score. Third, to construct a simple linear regression model using age as the predictor of energy level. Fourth, to interpret the regression slope, value, and prediction from the model. Now, I would like to present on our method of data collection. So our data is secondary data, which we have obtained from a primary research, another research article. So our dataset information is that we have gained it from Figshare, and our URL we have provided right here below. So the file name is breakfast and energy level dataset. The sample size for our data is 40 respondents, but as you can see, there are only 10 respondents here. This is due to the limited space that we have to provide the full 40 respondents. So if you wish to see the full 40 data that we have used, you can check on this link right here. So population is university student. So any university student from the age of 18 to 50-year-old. So this includes a master PhD students. Our variable includes age, gender, breakfast eaten, breakfast type, physical activity level, and subjective energy score. Now, the reason we chose this dataset is that only numerical variables can be used for correlation and regression. Among all variables provided, age and energy score are the only suitable numeric variable for statistical modeling. Moving on to our next slide. So here I would briefly explain about the table right on the left. So our variable, we have age and subjective energy score. So the type of data is numerical and continuous for both data. Now for age is an explanatory variable which is provided by our respondent, so we can see what are their ages. Description: age of each participant measured in years used as the predictor in the correlation and the regression analysis. Now for our variable subjective energy score, it is a response variable which we would like to see the outcome of for our assignment. So description: self-reported daily energy level on a scale from 0 to 10, used as the outcome variable in the analysis.
For our methodology, we first identified the variables needed for correlation and regression analysis. Since topic 2 requires quantitative data, we selected age as our predictor variable, which serves as X, and subjective energy score as our response variable, which serves as Y. Only numerical variables were chosen to ensure the analysis could be carried out accurately. For this study, we used Microsoft Excel to handle all stages of the analysis, including data cleaning, creating visualizations, and performing correlation and regression computations. Excel allowed us to organize the dataset, check for inconsistencies, and prepare it for further analysis. Next, we applied several statistical procedures. We began by creating a scatter plot to visually observe whether there was any relationship between age and energy levels. After that, we calculated the correlation coefficient to determine the strength and direction of the linear relationship between the two variables. Then, we built a simple linear regression model where age predicts the subjective energy score. From this model, we obtain the regression equation, the slope, and the coefficient of determination, which tells us how much variation in energy level can be explained by age. We also included a prediction example to demonstrate how the model can be used to estimate energy levels based on a given age. Lastly, we stated our expected relationship where we predicted a slight negative relationship. This is because generally energy levels tend to decline as age increases. The purpose of the analysis was to evaluate whether this assumption is supported by the actual data. From the scatter plot, we can see that the data points are quite widely spread, which shows a high amount of variation in energy levels among individuals of different ages. However, the regression line shows a slight upward trend. This indicates a very weak positive relationship between age and subjective energy level. In other words, although the data is widely scattered, older students in this dataset tend to report slightly higher energy levels compared to younger students. Next, based on the regression output, the value of coefficient of determination is 0.0912. When we convert this into the correlation coefficient, the value is approximately plus 0.30. This confirms that the linear relationship between age and energy level is weak and positive. This means that as age increases, energy levels do increase slightly, but the relationship is not strong. Overall, the results show that there is a mild upward pattern. Older respondents tend to have slightly higher energy scores, but the trend is very weak due to the large spread of data points. Therefore, while age does show a positive influence on energy levels, it is not a strong predictor, and there are many other factors likely affecting the energy score.
Next, we will explain the findings from our correlation and regression analysis. First, based on the regression equation, we obtain y equals to 0.0416x plus 2.461. This equation shows that as age increases, the predicted subjective energy score also increases slightly. However, the increase is very small, which already suggests that the relationship is not strong. Looking at the slope, which is b equals to 0.0416, this means that for every 1 year increase in age, a student energy score is predicted to increase by only 0.0416 units. This indicates a very weak positive effect of age on energy level. Next, the coefficient of determination is 0.0912. This tells us that age only explains about 9.12% of the variation in subjective energy scores. In other words, age is a weak predictor, and most of the variation in energy level is influenced by other factors that are not included in our model. Finally, for the prediction example, if we take a student age 30 and substitute it into the regression equation, y equals to 0.0416 multiplied by 30 plus 2.461, y equals to 3.71. So, a 30-year-old student is predicted to have an energy score of approximately 3.7. This helps demonstrate how the regression model can be used to estimate expected energy level based on age. Overall, the findings shows that although there is a slight positive trend, the relationship between age and energy level is very weak.
To conclude our analysis, The results show that there is a very weak positive relationship between age and subjective energy level. Although older students in the data set tend to report slightly higher energy scores, the trend is not strong and the relationship is not very linear. This means that age alone does not explain much of the variation in energy levels, and many other factors are likely influencing how energetic students feel throughout the day. In terms of limitations, the dataset includes participants with ages ranging up to 60. Even though it was described as university students, this may affect how well the data represents a typical student population. Additionally, the energy scores were self-reported, which means the results may contain some response bias. Another limitation is that only one numeric predictor variable, which is age, was available for the regression analysis. This restricts the model's ability to fully explain variations in energy levels. For future work, the study can be improved by including additional numerical variables such as sleep duration, caffeine intake, or physical activity level, since these factors are known to influence daily energy. Collecting a dataset with clearer or more consistent age grouping would also strengthen the analysis and make the results more representative of the target population. Lastly, breakfast habits could be explored more deeply using descriptive statistics or even analysis of variance in a separate study to understand how different types of breakfast influence energy levels.